Hi guys. So in today's session, we will look at a few other methods in the Enum module. And the first thing we'll tackle is the reverse method because we've cheated a little in our previous session and used the actual Enum reverse method to do the reversing. But let's get rid of that and let's write our own implementation. Okay. So um, all right, so what we're going to do here is we're going to, let me just copy a few lines from here and describe enum.reverse, right? And let me close the end there. Should reverse a list, okay? And what we have here is, let's say we have enum123 and naive enum. And I'm just going to say that, well, what is that? Reverse A should give us 3, 2, 1. Right? That looks good. And I actually am using a small library called Mix Test Watch, which is very handy. It runs your tests whenever something changes. Okay, so that's what's running in the pane below. Okay, anyway, the tests are failing. It's probably not even compiling. Okay, so what we need to do is we need to actually add a method here called reverse, which takes some list, and for now let's just return the same list and make it pass. Right? Okay. So now if you look at the failing test, it says it's not in the right order, which is good, right? Now, so what we want to do here is okay. So before we write this, we need to understand how lists are built in Elixir. Okay, so in Elixir uses linked lists, which means you have a head and it's pointing to the next element, and which is pointing to the next element, and so on and so forth. So there is, so this is what is a linked list, and with linked lists, getting the head is very easy because that's the first element you have access to. Getting the second element takes two operations, right? You go to the head, then you find what the next node is, and then you get there. And going to the third element takes three hops. Okay, so anyway, what we want to do is we want to optimize knowing how these are built. So what we're going to do is we're going to take the head and create another list where that element is going to be at the end of it. Okay, so well, before we write this test, let's write an easier test, right? So we'll say test empty list should return an empty list, right? So this is actually an easier one, and I think we've already implemented the code to handle that. Okay, so if I say reverse an empty list, it should return an empty list. And just to make sure that we have a valid test, I'm just going to make it fail. So we have a red, and now I'm just going to make it pass. Okay, so it's passing now, and we can actually write that down. Okay, so when we have an empty list, we want to return an empty list, right? And while doing a reverse, what we want to do is we want to get the head of the list, right? And let me just type it out, head, and we want to get the rest of the list. Okay, and then what we want to do is we also want to keep accumulating the other list, right? So what I'm going to do here is I'm going to step back a little and say when you call reverse list, it is going to call another method, another function with an empty accumulator. Okay, and we're going to write that function as something which takes if it gets an empty list, and if this is the accumulator, it's going to return the accumulator. Okay, so now all our tests pass, but we're also writing our function in a way that we get an accumulator by default, which is going to be an empty list, right? Now, if you think about this, and if this list has a head and a rest of the list, what we want to do here is we want to, let's think about this, right? So we have, let's say, this is one way I picture the input and I try to see how the code should be. So let's say we have 1, 2, 3, which can be written as 1, 1 pipe 2, 3, right? So it's 1, which is the head, and 2, 3 is the rest of the list. And let's say the accumulator is an empty list. So what we want to do in this iteration is we want to change this to become, okay, so the accumulator is empty. What we want to do is we want to take that 1 out of there and add it to the end of the list. Okay, so if it is an empty list like that. And in the second iteration, what we want to do is take the 2 and add it to the head of that list. Okay, and in the third iteration, we wanted to add that 3 to the actually I can get rid of these. Okay, so here we have, let's say that's the accumulator, that's the list, and that's the accumulator. Okay, so this is the progression I want. Okay, so the way to do it is we just get the head and we call reverse again with the rest, and we append our head to the accumulator. Okay, so now actually doing this, so let's write a test to actually test something, and then we'll write the code. Okay, so I'm gonna uncomment that, and it should make the test fail, right? Because no function clause matches. Okay, so this is actually an error in our code. So I'll just say if we get a list, I'm just gonna return the list. Okay, this is a bad implementation, right? This is a bad implementation. But what we want to do here is, instead of that, we want to do this, right? What do we want to do? We want to call this, okay? And all our tests now pass, okay? And let's just run it with maybe a big list, right? So I'll say enum2 list this. I'll actually so 1 to 10. Alright, so I'm going to say 1 to 10 is a range which I'm going to push through enum2 list, and I'm going to call reverse on it. Okay, and this reversed list, right? So I'll say reversed list should be the same as enum2 list 10 to 1, right? So in Elixir, ranges can even be from in a max to min, right? From a greater number to a lesser number. Okay, so let's see what's going on here. Now it says, oh, the test is duplicated. Should reverse a large list. Okay, so now it passes, right? So everything looks good, and we've written the reverse implementation, and we no longer have to use the enum provided reverse implementation. Okay, so that's awesome. Our tests are still passing, so that's good. All right, so we've covered a lot of we've just written one function, but let's see. Let me make a commit here, add it reverse, and what we're going to do then is we have reverse, we have reduce, we have map. We can look at filter and find. Okay, find should actually be an easier implementation, so let's look at find. So what find does is find, so let me go to the top here and copy a few tests. Right, so enum dot find finds a number in a list. Okay, so what we want to say find 1, 2, 3. If I say find 2, well, find actually, so let's take a look at the implementation here. Elixir Enum.find, right? So this is a function which takes a list and a function, an anonymous function, which gets that element from that list one at a time and returns a boolean, right? So we all know the find, right? So find takes that, and it also takes a function, an anonymous function, which should tell us if it is the right element, and this should return a single element, which is 2, right? So now obviously it's going to fail because we don't have implementation for this yet. So let's write out an implementation which takes a list and a function and returns, let's say, OK, right? So now it's passing, but it fails because we didn't find the right element, right? So let's think about this. Now, what we want to do here is we want to find an element in a list, and there's one way to get a single element out of a list, that is using reduce. So let's see if we can use reduce to implement this. Okay, so the way we're going to do is we're going to say reduce this list to a single element, right? And if we take a quick look at reduce takes a list, an accumulator, and a function, right? So the accumulator can be okay. Well, the accumulator can be nil, okay, and yeah. So let's that be nil, okay. So, and our function, right, so reduce takes a function which gets an element and an accumulator, okay. So it gets an x and an accumulator, okay, and returns us something, okay. So what we want to do here is we want to say, I'll just rename this to init, change this to init. Now what we want to do is we want to find if there is a function for which x is true, right? So we'll say if fun x is true, what do we want to do? We want to change the accumulator to found x, okay? All right, and if it is not, then we just keep looking, okay? So if we find it, all right, so we also need to return the accumulator at the end, right? So we'll say if fun is x, then we'll say found x, okay? Else, if we have not found it, then we'll return whatever the accumulator is currently, okay? And at the end, what we get, reduced result is this, and at the end, if we reduced result, if that is in it, it means we didn't find anything, right? So we'll just return an error. If that gives us found x, we'll return x, okay? So that seems like that should do it, but let's check it out, okay? So let's test this, and it fails because find 0 is undefined or private. Did you mean find 2 or find 3? Okay. So what's happening? Oh, yeah. So now it actually passes, right? So actually I'm going to put this in a different pane. Okay, so this passes, and And so this is a bit of a convoluted method where we are reducing a list, and if we find a matching element, we are returning it. Okay. Now let's say test finds a number in a list, right? Test finds a map in a list. Okay. So let's say we have maps in this list. Okay. And I'm gonna say name is Muju, right? And name is Zainab, and name is Sola, right? So what we have is we have a list of, kids, right, children. Now what we want to do is I want to find out the first child whose name starts with M, right? So for that, the predicate function would be, you would say you got X, and you want to see X dot name, right? Starts with M, right? So we'll say string dot starts with X dot name should start with M, right? And that should not give us 2, right? So that should give us name is Muju, right? That object, right? So it should give us this guy right here. It should give us this guy right here, okay? And all the tests pass, right? So this is good. Now, there's another test I want to write. I want to say find finds, okay, so returns the first match, okay? So now I want to find names which starts with Z, and the first name which starts with Z is Zainab, right? So now it fails because it returns Zora, right? So, and if you look at the code, that's what we are doing, right? If you find a match, we return that. So let's go through this list and see what happens, right? So it iterated first with Muju, and it said, no, this is not a match, so I'm gonna return init. Then it caught Zainab, so it found a match because Zainab starts with a Z, and it returned found X as the accumulator. And then it ran the same thing with Zora, right? And Zora also has a match, so it returns found X. And that's why we get the last element. And the other thing which is bad about this implementation is it keeps looking for elements even after it finds them, right? Because if you look at reduce is a function which takes a list and iterates over it, keeping an accumulator, right? It goes till the end. So this is not a good implementation for us, right? So so let's fix that, okay? And so let me uncomment this test, right? Because I want all my tests to be green before I refactor, and then we'll add that test, okay? So if you think about this, one way we can, so if we cut this implementation, right? If we cut that implementation, it's gonna blow, right? I mean, 2 tests are failing, which is good. And what we want to do here is we want to say, okay, a few things. First, what if it is an empty list, right? If it is an empty list, it means we don't have a match ever, right? So actually, I'm going to open up IEX and test it out real quick. So if I try to find something which says and 1 is true, okay, and 1 is okay. So it says nil, okay, so find returns nil if it doesn't find a match, right? So if we give it an empty list, there's nothing in the list, so this should return nil, right? So that's good, and we should write a test for that, okay? So test find returns nil for empty list, okay? And if we say assert find empty should be equal to nil, right? And also find find should finds a number, right? Okay, so returns nil if it does not find a number in a list, right? So if I try to search for 5 or 6, it should return nil. Right? So this is going to be a failing test, right? Well, undefined function find 1. Find 1. Well, yeah, find this, and 1 is okay. Some function, right? And now they are failing, so which is good. Okay. So now let's think about the implementation. Right? If it has at least one element, right, which is head and rest, and we're saying if we check for head, if it returns true, we return the head. Otherwise, we try to find it in the rest of the list, right? So that's something which should work, right? So let's see if all our tests are passing, and they are passing. And this is actually a much simpler implementation, right? All right, so let's uncomment our last test and make sure our tests still pass. Okay, so that's good, right? So find has a simple implementation when we actually write the implementation instead of reusing reduce. Okay, so this looks good, and